This morning, let's take a look at a couple of gas law stoichiometry calculations. This question actually, there are two problems, two calculations that we need to conclude from this question. First, it says find the mass in grams of 7.2 liters, that's a volume measurement, of chlorine gas, which is got the chemical formula Cl2, at 19 degrees Celsius, so let's change that to Kelvin. Always work gas law problems in Kelvin. And remember that Kelvin is equal to the Celsius plus 273.15. Here with sig figs, it's going to just end up being 292 Kelvin. And our pressure is equal to 0.959 atmospheres. So we want to find the mass. Okay, let's first set up the ideal gas law equation. With gas laws, the calculations aren't overwhelmingly challenging. There's just a lot of values and a lot of variables to keep up with. So I strongly recommend that you write the equation, label the values, and then you can do some substitution. So we have pressure is 0.959 atmospheres. Volume, you want to make sure it's in liters because of the universal gas law constant, the R. Okay. N is equal to moles. Now here we don't have a mole value, and we're supposed to be looking for mass. But we're going to solve for moles, and then we'll convert it to mass, to grams, using the molar mass. Okay. Our R, universal gas law constant, 0.08206. Now you may see it as 821, not 06. Just use whatever's available in your textbook. Okay, and the units on that, some unusual units, it's liters, atmospheres, moles, Kelvin. Okay, and then our temperature is 292 Kelvin. Okay, so we've got this set up. Now we just solve. So let's go 0.08206 times 292. Okay, that gives us 23.96152. Now I'm carrying extra digits here on sig figs because I don't want to round midway through the problem and then round a second time at the final answer. 6.9048. Okay, and then we'll divide these out. Now this is solving for N, which is moles. The question is asking for mass, but that's okay, we'll get moles first. Okay, so our moles is 0.28816 and so forth. With sig figs here, we'll be looking at 2 sig figs, so it'll be 0.29 moles is what we would technically be using. Okay, but I really don't want to round this answer until the final answer. Okay, but with sig figs it would be 0.29 if we were solving for moles. So let's keep this 0.288 value here, and we've got that many moles of chlorine gas. Now chlorine gas is Cl2, so I'm going to convert that. 1 mole of Cl2, and remember that molar masses come from the periodic table. We just take their values, add them up, okay, and chlorine has a molar mass of 35.4527, so I'm going to multiply that by 2, so I'm going to have 35.4527 times 2, so the molar mass is 70.9054 grams, and we solve this. Oops, and I just realized I have my conversion factor upside down. We want grams, so that should go on top. So let's multiply these rather than divide. Apologies. Okay, so with 2 sig figs here, because we're backtracking all the way to 7.2 liters and 19 Celsius, it would be 20.432 grams of chlorine gas there in our calculator. We round to 2 sig figs and it is 20 grams of chlorine gas, and that is our mass. Okay, So my apologies, I got this upside down here. All right, so now the second part of this question. Okay, the second part, we are to find the volume of this gas at STP. Okay, now let's remember that STP is a pressure of 1 atmosphere, standard pressure, a temperature of 273.15 Kelvin. Okay, that is our standard temperature and pressure conditions. We are hunting for volume. Again, I strongly recommend that you write down the values and then do a substitution, because there are quite a few values and variables here to deal with. Our R, we use the same R, 0.08206, okay, liters, atmospheres per mole Kelvin. And our N, we're needing N. Where do we get N? Well, we solved for it back up here in the previous problem. So 0. And I'm going to go ahead and round it to 0.29, okay, with the sig figs. Okay. And we have all the variables we need. All we got to do is solve for volume. So we have PV equals nRT. So pressure is 1 atmosphere, volume is unknown, N is 0.29, R is 0.08206, and temperature is 273.15. Okay, and we solve. So we have 0.29 times 0.08206 times 273.15 divided by 1, which really doesn't make much difference. Volume, and let's go to sig figs here, 6.5 liters. And that would be our volume at standard temperature and pressure conditions.